Thank you, everyone. My name is Alexandros Kosiaris, but please call me Alex, as I've said. I live in Athens, Greece, and I've been with the Wikimedia Foundation for the past almost 12 years now. And after all this time, you can probably find my fingerprints in more parts of the infrastructure that you can't. Current focus is varied, but I've been at the forefront of the migration of MediaWiki to Kubernetes for the last couple of years. I'll be broaching a slightly difficult topic, so I have a request from everyone in the audience. I will be speaking about people living this world, people that some of you might be holding dear, and how that impacted us at Wikimedia. It's a difficult topic that I've been searching for some time to figure out how to approach. I think I have such an approach now, but I am human, I might err, I might just sound wrong to you. If I do, I just ask for your forgiveness. So, who's Wikimedia? One thing that I can tell you is that we have nothing to do with WikiLeaks. It's this nonprofit 501c status in the United States that is handling the infrastructure for a variety of projects. This is just a sampling. You probably know the top left one, Wikipedia. There is also a set of other ones like Wikidata, which, by the way, is going to be in our story. All we do is we run the infrastructure. The content itself, the edits, the reverts, the endless debates about what actually belongs in Wikipedia and what doesn't, it's all by volunteer community who are unpaid. We are the only nonprofit, I think, and only an open source and group of open source projects that is also a top 10 website. How do we run? All of this, almost all of it, is our own metal. Rented cages, colocation providers, we're going to see in the next slide where. We have very limited use cases for public cloud providers. We do have a private cloud. And not for anything, for just a direct user query path, which might contain, well, probably contain PII, also known as personally identifying information. We are, as an org, very heavily concerned about the privacy of our users, and so are our users. So we're trying to limit in any kind of way who can get access to that one. The other angle is, of course, cost. So all of you that run on public clouds probably know about cost. This photo is from Dallas, Texas, a little bit dated, 2015, but it's a typical rack that we have there. Overall, we have around 2,200 physical servers, 1/10 of that being also VMs, and we are in 7 locations, which we're going to be calling core plus CDN, and another 5 that are just a CDN. This is a map. You can see there are some weird acronyms in there. Those are the names of our data centers. Like if you hear people from Wikimedia talking about these are the acronyms that I'm going to be using. And how do they show up? It is a combination of 2 letters for the name of the commercial provider, like for example, EQ stands for Equinix, and the nearest 3-letter airport code. This has served us for the last 15 to 20 years, but it's not aging well because at the time of mergers and companies renaming themselves and CEOs making decisions about wanting to do something else different with a company, this changes. Magru, the one in Sao Paulo, which is our newest data center, which is coming online and serving more and more traffic this last quarter, is named completely arbitrarily, as if the previous thing wasn't arbitrary enough. So we have 2 core sites, one in Ekiad and one KTFW. They are both in the US, and they're running more or less everything, plus what we call the CDN component. The other 5 have just the CDN component, and when I say CDN, by the way, like I mean reverse caching proxies, HTTP reverse caching proxies. They all have their own public IP ranges, and we do geographic DNS routing based on the resolver's IP. We aren't yet doing anything fancy like Anycast or something like that on the DNS level. Maybe we'll do someday, but for now, this works and has worked for at least 15 years now. Pretty straightforward, easy to understand, easy to onboard people. So I've been talking a little bit about, I want to talk a little bit about MediaWiki, which is our core application. Right now, it has gone through a massive transformation, and up to at least a year ago, it was 2022, it was in app servers, bare metal boxes. Now it's in a Kubernetes pod that has in it various things like, it's a LAMP stack. It has an Apache, a PHP, Envoy for TLS elimination, a couple of other components. To give you an idea of our scale, this is just a snapshot that I took the other day from our very public Grafana site. Like, as you can see, we are never below 100K RPS, usually not more than 200K RPS. RPS stands for request per second, except those weird spikes in there, which we'll talk about some of these spikes in this talk. Overall, we have around 20 edits per second across all projects and all language families. This is around 1,000 wikis, so do the math. So story, how we fared from 2009 to 2020. It's 25th of June, 2009. Wikipedia is 8 years old, and it has all the goods and all the bads you can expect from an 8-year-old. The parents among you probably can relate. And Michael Jackson departs from this world. And Wikipedia collapses. The collapse is visible. There's actually a New York Times article about it. For an 8-year project in the tech industry in 2009, that's something. The thing is investigated, and solutions are proposed and actually implemented, and they function the very next day. And a Wikipedia page is created about the event, and it's called the Michael Jackson effect. And you can open up your phones after the session, please, and look more about what all it is about. But the gist of it is in that spike at the end where I just added our Ganglia, a Ganglia screenshot for back then in 2009. Like, remember, this is 2009, no Grafana, no Prometheus, no nice things. Like, we just had Ganglia. And you can see CPU usage skyrocketing. By the way, I'm a light mode person. Like, this is dark mode. This is dark mode that was added by colleagues of mine in the foundation very, very recently. Funnily enough, it follows the Pareto principle. It's very easy to enable dark mode in Wikipedia. It used to be very easy to enable dark mode in Wikipedia for 80% of the pages. All you needed is a couple of CSS tricks, and it worked. The rest 20% of the pages took so much work to get done because of the various colors. So I'm really happy that it's here now, and it's very easy to enable. All you need is to click on Tools. There is a submenu that appears, says Appearance, and you can just enable dark mode. So what happened during the Michael Jackson incident? Well, it's your typical cache stampede thing. To give you a little bit more information about this, every Wikipedia article has many revisions. And during an edit save process, which is when someone edited something and just clicked the submit button, Wikitext, which is this markup language that predates Markdown, but it resembles it, and as well as the other markup languages like ASCII-Doc, Pandoc, whatever, is parsed. And there are pages that are parsed very fastly and quickly, and there are pages that even today, despite all of these improvements that we have had in CPU performances, they can take more than 30 seconds to parse. Fun fact, right before this session, like as I was looking through the slides, I did look at the report for Michael Jackson's page. A clean parse requires 13.3 seconds. So what happens after the page is parsed successfully, hopefully? The page's entry in the cache, which we call a parser cache, is overwritten. And then the other cache is purged. So in computing, well, I made this joke 5 years ago in this exact stage, and there are, in computing, two things that can go wrong. One is naming, the other one is cache invalidation. Who's gonna shout the third one? Thank you. So this is exactly what happened. Cache invalidation errors, race conditions, edit rates skyrocketed because for some reason that eludes me, absolutely eludes me. People wanna be the person that changes the is to a was, and they wanna be the first. And they are there, and then the rest are like, somebody beat me to it, let me see what else other changes I can do. And the moment after the event happening, there is so much edits that happen in that point in time. And then at the same time, there are views rates that skyrocket as well, because everybody wants to know at that point in time who that person was, because they didn't know. Race conditions, multiple servers try to parse the exact same page, probably the exact same revision. And it takes time, and we're out of capacity. So what happens? A colleague of mine, Tim Starling, remember this is 2009, Redis doesn't exist. If it had happened later on after Antivirus released Redis, we would probably have used Redis or something similar, creates a small C daemon, which also comes with accompanying MediaWiki core code, and it's nothing but an in-memory distributed mutex. And by distributed, I don't mean they can talk to each other if you're on multiple daemons. It's just every single one is dedicated, but you can run it, but you can run MediaWiki across a couple of these, and then what you get is, at most, a couple of servers will be parsing a specific page's wiki text. Protocol is very simple. You can say things like acquire for any, acquire for me, and you can get a lock, and then you release the lock, and then informs everybody else who is trying to acquire the lock that, hey, you know what, it's done. You don't need to get to do the work again. Just go to the cache and grab the content. So, we are up the next day. And I've been picking numbers from this then recently created article. It was created barely 3 months before the incident of Michael Jackson. And the highest ever count that was documented in that article was dwarfed by Michael Jackson's death. Michael Jackson on that day, 1.4 million views. Very next day, 5.9. It worked. And time goes on. Life goes on. And various celebrities leave this strange world. And people visit to change that is to a was, and they edit Wikipedia. And you got Amy Winehouse, 4 million views, 2.3 the very next day. And staff and volunteers recount the tale of what the Michael Jackson effect is. Steve Jobs, 7.4, 1.6 the very next day. And the tale continues to be passed from volunteer to staff mouths, and we have Whitney Houston, 5.1 in 2012, and Paul Walker, which is a few months after I was hired in the foundation. And it was the first one, and I was naive, so naive, because I believed, after hearing the story, we were gonna be okay. And we were, and that reinforced my naivete. But boy, was I naive. Then, the tale continues to be told, and I repeat the tale without having witnessed it firsthand. I just repeat it. Sometimes in awe, sometimes in wonder, sometimes in fear. Nelson Mandela followed pretty soon after Paul Walker. The astute among you probably noticed that it has less million views than Paul Walker. You might be tempted to say politicians might be less interesting than singers and TV stars. I'll counter this by saying that if you go to that article that I showed you earlier, 2 past presidents of the US dominate that page with 2 and 4 entries respectively, and they're both alive. Sometimes something small happens. 2014, Robin Williams goes away. It's the first with an actual incident, but with the expected outcome. Poll counter got triggered. People got back an error. We saw it relatively quickly. A colleague of mine asked the English Wikipedia community to protect the page. Protect is a term that we have where a circle of people is the only one that are the only ones that can edit the page, which thankfully limits all of this a lot. I remember being able to grieve Robin Williams. Then, the composer and singer of When Doves Cry, which is one of my favorite songs, passes away as well. And this one lasts. And poll counter gets triggered really badly. Huge page views for days, blog posts, Hacker News articles. People were actually getting back the error and reporting and say, look, like Wikipedia, it doesn't allow me to edit. But things, again, work as expected. It's just that, like I put the graph in there because it lasted 4 days. 5.8, 5.5, 2.1, 1.4 million views. Right? It was quite a bit. And we survived, but after all of this, like, anxiety was clear. I don't remember being able to grieve during this. Like, I have email threads in my inbox. I was looking them up, and yeah, it was a weirdest situation. So, 3.5 years later, January 26, 2020. COVID was about to hit hard. We had no idea. And we have our last all-hands event, where everybody from the foundation is supposed to meet in San Francisco. And helicopter crash, horrible accident, Kobe Bryant passes away. And that happens right the day of DDoS attacks, and Wikipedia collapses. People were in planes, in airports, jet lagged, tired. Poll counter did not save us that day. And the fear in the tale manifests. So in my all 7 years in foundation up then, Like I have never seen such a steep increase as the one that you see here. By the way, this is sampled, 128. So multiply and you'll see that the peak is a little bit more than 6.5 million. We probably lost stuff that's not in there because it collapses. And that's only English Wikipedia. The Greek wiki, which is my home wiki, another 100K views that day. The French Wikipedia, 673K. German, 570K. Spanish, which is actually a really big Wikipedia, another 1.1 million page views that day alone. And it's never the page of the person that leaves. It's an entire family of pages. LeBron James's page, another 100K page views. Joe Bryant's page, which is Kobe's father, 300K page views. A page was named Death of Kobe Bryant. It was created by someone and had another 200K page views. And why? Why did all of this happen? I do not believe in single root causes in complex environments. That means never a thing. It's always more than one thing. And I'm listing some things that we identified and I think they're there. So we were jet lagged, tired, sleeping on planes. I remember being at a lounge in Istanbul trying to respond to this. There was the DDoS attack right before the event, had depleted the whatever dwindling resources we had because not everyone was around. Event was saddened. This is critical about this one. It was really saddened. The previous one was years ago. We didn't have the experience really fresh, so it was weird, and we believed that pull counter was going to save us. Wikipedia usage across the world had increased, probably a lot, but our investment in it, in the infrastructure that supported it, probably hadn't. And finally, Wikidata, which is a project that was started in 2012, had become by 2020 a major data provider for Wikipedias. A regression had been inserted. We will be talking about it in a while. So what do? We actually need to invest to make the sites better. And COVID didn't help with this. So we ran a postmortem. We already had an incident response process and protocol. We went through our incident docs and statuses, and we decided on the following. So we beefed up our DDoS protection. We altered how Wikipedia and Wikidata communicate with each other so that it doesn't, so that we remove the regression. We increased memcached capacities because we identified that we had such an issue. We decided to utilize our secondary data center, improve our incident response culture and processes, improve onboarding, and never ever travel again, which is not true, but well, COVID has indeed forced reduced travel. Let's start with the easiest one. Again, the DDoS itself did not contribute to Kobe Bryant's death, but definitely did not contribute to Kobe Bryant's death, to the incident that we had due to it, but it did deplete the already dwindling SRE forces. So we had some DDoS scrubbing suppliers already. We procured more, we went into deals, worked with them, reported bugs. Oh boy, there were bugs. We requested functionality from them, they obliged. So we ended up with writing a playbook, writing cookbooks, integrating their APIs into our cookbooks, trained ourselves to use it. It was easy. We were constantly under attack at that point in time. I should note here that no matter what DDoS suppliers use, they are different DDoS suppliers depending on data center, they never terminate the traffic. It's always encrypted end-to-end, only we have the keys to decrypt that traffic. They just insert themselves, with our permission, in fact, are triggering via our cookbooks in the routing path, doing some well-thought BGP shenanigans, and then they scrub the traffic. And this is very useful against two very common types of attacks: volumetric attacks, where they just try to saturate everything, and scene attacks, TCP scene attacks, where they just try to saturate your load balancers, essentially. Wikidata changes. What did we do with this one? So let me first say a little bit about what Wikidata is, which is an open knowledge base of structured linked data. And it powers a lot of info boxes in Wikipedia these days. What's an info box like? You can see on the right-hand side this very, very appetizing crostata. Ignore it, please. Let's focus on the text below. And it says things like, it's a tart, it's a dessert. It comes from Italy. So this is a typical info box. There is this component that was part of Wikidata and Wikibase, which is called Babel, which creates info boxes that have to do with editors' language proficiency. So you can see that if I talk to person X, which is an editor, by the way, not a viewer, they know these types of languages and at this type of proficiency. So what happened here is, it's probably not obvious how these two are related. And in fact, it would be a surprise if it was, so let me walk you through it. Babel failed. The reason that Babel failed was that it uses this failure mode where it first goes to talk to memcached, and if it can't, it will switch to using an expensive HTTPS API call to itself to fetch the data that it needs. Queuing memcached link saturation because of the Kobe Bryant part. So two completely different things coalesced and created a huge incident. Again, Babel itself had nothing to do with the Kobe Bryant incident itself. They just managed to converge and create all of this mess. So what do we do about all of this? Multi-pronged effort. First of all, we decided that paying expensive HTTPS API calls for failure modes didn't make any sense. We had other problems as well with other services, and we invest in a service mesh. It's Envoy-based, which is the multitude, I think, of service meshes out there. And it essentially does persistent HTTPS connections. It also adds retries and circuit breaking, both of which have been somewhat useful. As far as memcached itself goes, first we invested in a local memcached instance per MediaWiki server so that we could absorb that really high traffic lookups when they happen, and then we invested into a centralized memcached gutter pool, as Facebook calls it. We use this component called MacRouter from Facebook Meta that allows us to do all of this. And then we switched Babel from, instead of talking to itself, because it's a MediaWiki component, instead of talking to the API via HTTPS, to actually go via the more correct route, which was your MediaWiki yourself. Just talk to the database and fetch the data from the database. We don't have to pay all of this cost. The other part where we invested in extra capacity was multi-DC. So as I said, like we have two core DCs. What I didn't say is that we haven't been until 2022 using them simultaneously. They were always in an active, passive role, with some asynchronous jobs being executed on the secondary, everything being on the primary. We've been occasionally switching to the secondary for a couple of months or weeks to test that if the entirety of the primary is dead, can we actually survive on the secondary? But that is what we have been doing up to then. The capacity was mostly left unused. So what do we do is, in 2015, by the way, we identified that we're on an RFC, an internal RFC in the, well, it's actually a public RFC, across the entirety of the foundation and communities, and implementation started happening in stages. I'm not gonna cover the stages before 2020 because there are a lot. I'll focus on 3 selected improvements that happened since 2020. So we have CDN improvements. I'll talk about the session store, main stash improvements, and some weird cross-DC MariaDB secure writes. By the way, one of the 2 DCs is always read-only. The other one is read-write. I'll be referring to them with these terms. And they are 40 milliseconds RTT apart. CDN improvements. Which DC should I request land to? We start with the fact that if it needs an HTTP post, people are probably submitting data. It needs to go to the read-write DC. Or they can forcefully ask, and some extensions and tools do that, to go to the read-write DC. That weird thing that is called CP post index, it is code word internally to tell you that they probably made an edit. You want to see the result of your edit most probably immediately. You do not want to be in a situation, wait, where is it? So you go to the read-write DC. Various single sign-on workflows go to the read-write DC, and then everything else goes to the local DC, where local means your closest. We also invested in our caching validation. It used to be UDP multicast scheme, and as packets in UDP can get, you can complete the rest on your own. We switched to a Kafka-based local daemon per CDN node that reads Kafka topics and then actually purges the pages. Let's move then to what is the main stash and the session store. First, let's go with sessions. Sessions used to be in the long past before I joined in memcached. Then they realized that a memcached instance being restarted, you lost all the sessions, so it moved to something with persistence, queuing Redis. Turns out that Redis, including Lua scripting, including 40 millisecond round trip time and replication to the other data center, And big sizes isn't a really good solution, but we already had Cassandra for a different project, and Cassandra is pretty good about being eventually consistent. And for sessions, you can be eventually consistent. You don't need strong consistencies. The problem was that PHP didn't have a good library for talking to Cassandra, so we used a Golang proxy. It's a really thin layer named Cask that essentially just translates HTTP to SQL. Sessions now are in both TCs. We're happily peaking at 1.5K requests per second, and it works. It's now, I think, mature enough. It did cause its incidents, by the way, like as everything that gets deployed for the very first time. And let me now move to main stash, which is its code word in MediaWiki land for something that is a dumping ground. So every developer out there that wanted to store some data somewhere and they couldn't get a hold of a dedicated data store for that, and it was smallish and all, you just put it into main stash. MediaWiki, by the way, is this software that it's 20 years old, and by now it has so many abstraction layers that you can see the PHP call function there, and I'm pretty sure that it tells you nothing. It's because it's so many indirection layers, like you cannot see what actually implements this. So it used to be that it was implemented in Redis for non-critical, primary, that is non-derivative data, and it needed some strong persistence. We've been talking amongst teams, like figuring out how to maintain this. Turns out that you can abuse, relatively successfully, a RDBMS like MySQL or MariaDB as a key value store. And that's what we did. However, there were a couple of issues. We have edge case handlings for reasons, historical reasons, and an action can result to a DB write and end up in the wrong DC. This is a case where you'll say, what do you mean edge case handling? Like, what is this about? Remember how I said HTTP posts are almost always writes? Gets can be writes as well, which is wrong, but what can you do with software that is 20 years old and has APIs have ossified and you cannot really change them because you also release them to the public and everybody uses it. So an identified use case, by the way, for this one is SSL login extensions and rollbacks. So what happens there is that we went through a process of figuring out how to make MediaWiki talk to the other DC 40 milliseconds away over SSL because it was Snowden revelations and all, using TLS and all. But after evaluating various approaches, which included ProxySQL, Envoy, and proxy in TCP mode and all, it turned out that those edge cases were small enough in size that you could just do it having the MediaWiki talk directly with TLS to the other data center in my MariaDBs and not have issues. And it's just that small size that makes it okay. It's not generically a good solution. Okay, so what changes did we do in culture? We had, as I said previously, an incident response process set up, including incident status doc. What we did not have was structured post-mortem meetings. They were kind of ad hoc among people that just wanted, they were not particularly advertised. So we introduced the typical blameless post-mortem meetings that you can think of, review incident docs, discuss, figure out causes. How people learn via this, it's a really good way of having people learn, especially newcomers. Share experiences and all that, the typical blameless postmortem thing that you can think of. And it's overall been a very good success. And onboarding-wise, we are now almost exclusively remote. Like there is a headquarters in San Francisco, but it runs just some administrative stuff. So we were remote heavy pre-COVID anyway, but we all had our interesting onboarding tales, which are things that can happen from anything between time zone difference to the limbo time zone that exists between the US and the EU across 2 weeks per year. And we recognize the deficiency and invested in a proper onboarding framework. COVID helped with this because while SRE was already very remote heavy, there were some parts of the organization that hadn't fully embraced that. And once they did, they saw the need for a better onboarding, remote onboarding process. So you get on your own onboarding buddy when you join. You have a checklist of things in a wiki page that you need to go through, and with their help, tick them one by one. And incident response is part of this onboarding process. So we did all of this. Did it work? So the big thing about all of this is that you cannot know if all the things that you did actually worked until you got a strong, externally driven data point about this that verifies all of your work. So from 2020 until late 22, what happened is that in SRE, we were unable to grieve the passing of any celebrity that we cared for. And then 2022 happens. And Elizabeth II dies on the 8th of September. And I have to tell you, this one had me scared. It was 9 p.m., I think, for me when the thing hit. And I knew it would go really, really badly for both staff and all the communities. But it didn't. It didn't because I think of all of these things that I already talked to you about, plus one more. The whole new world knew this was coming. So we actually had some time to prepare, especially the communities. The communities here were super important. They started locking down pages early in the day, and one of my beloved justifications from one person in there was like, I'm locking down this page just to protect it to trusted volunteers to limit that silliness, which was, it was nice reading it at that point in time. So again, an important thing to point here is that we're just talking about page views on a single page up to here. This is Elizabeth II. Every single member of her close and extended family probably had some change in title or whatever, including changes in things that you would not expect, like cruise ships. So I think that in this room there are people that day grieved her passing, there are people that did not. I'm in the latter group, but I did grieve this one. I was probably able to grieve this one. Matthew Perry left on October 29 of 2023. It's definitely a way smaller signal. It's still 9 million page views on the day of their death. One thing to note, by the way, here, like all the images, you've probably guessed already, they're not AI. They're all straight from Wikimedia Commons, where everything is either CC by SA, Creative Commons license, or public domain. And I think with that, I can thank you, first of all, for listening to me. I'd like to leave you with this list of people that have been crucial in implementing the mitigations that I've talked about, including the idea of how to present this to you, which I hope was successful. That would be Giuseppe Lavaghetto. And I'll leave you with one of my favorites from Stephen Hawking quotes: be brave, be curious, be determined, overcome the odds. It can be done. Thank you for listening.